Welcome to Study Loop.
For setting up this problem, we're considering the fact that the potential energy U is equal to Z, the atomic number, negative Z, the atomic number, times the charge squared divided by 4 pi times epsilon naught times the radius of orbit r, where the total energy from the virial theorem is 1/2 the potential, U over 2. So replacing U in this equation with our expression above, we have E is equal to that, but instead of 4, we have an 8 now from the 1/2. So for nitrogen 6 plus, Z is equal to 7, and R is equal to A over 7. So for A, to calculate the ground state energy, we simply have to plug in these values. So we have negative Z, where Z is equal to 7, times the charge squared, where the 2.6 times 10 to the minus 19 coulombs, divided by 8 pi times epsilon naught times R, which is equal to over 7. So this comes out to negative 666 electron volts. Part B wants us to find the ionization energy, but the ionization energy is simply the magnitude of the ground state. That's how much energy it takes to move it from the ground state. So this is equal to 600 electron volts. Part C wants the distance A for this ion, or R, excuse me. So R is equal to A over 7, so it just wants us to guess where A is Bohr's radius, of course. So this is 5.29 times minus 11 meters divided by 7. So this comes out to equal 7.56 times 10 to the minus 12 meters. And now for D, we have to calculate the wavelength of the photon emitted when the nitrogen 6 plus makes a transition from n equals 2 to n equals 1. So since we have E1 is equal to negative 666 eV, that's our ground state energy here, we can calculate E2 because our equation, this E2, back and relabel this as E1 up here, since this is our ground state. So this is E1, this is the magnitude of E1. E2 is equal to E1 by A squared. Is equal to 2, so divided by 2 squared, which is 4. So taking 666 electron volts and dividing it by 4, we get 166.5 eV. Negative, of course. Oh, that's not our answer. So to transition from the E equals 1 to the E equals 2 state, E is equal to minus E1, the difference between the two states. This is equal to 200 volts. Or 499.5 electron volts, sorry. So with that, we can now calculate the wavelength, because E is equal to hc over lambda, or lambda hc over E. Planck's constant in electron volt seconds, so 4.136 times 10 to the minus 15 electron volt seconds. C is the speed of light, 3.8 meters per second, and then E is the value we just calculated above. So 4.136 times 10 to the minus 15 times 3 times 10 to the 8 divided by 499.5 comes out to equal 2.49 nanometers, which is 0.49 times 10 by 9 meters, or 2.49 nanometers. Let me give an resolution.